1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! And welcome to Mr. Moore's online flip classroom, and once again, boy am I excited to be with you guys today because we are going to look at how to solve logarithmic equations. Now before we get too far into the lesson, there are a few things that you need to know when performing this skill. So let's check out a little bit of a rundown on the things that you must know when solving logarithmic equations. Let's check it out.
So today we're going to have a look at how to solve logarithmic equations. Now before we do this, there's a few things that we must know when solving logarithmic equations, and these are: the logarithm of a negative number or 0 can't be defined, so that is log a to the x exists for any x value greater than 0 as long as a here is a positive. The next thing to know is that there are 4 positions where the x may be located, and these are in any of the 4 positions that you can see here. For example, x could be in position 1, position 2, position 3, or position 4. Now of course, based on the position that it's in is going to determine how we're actually going to go about solving this, because it will require a different method for each position. And the third thing is logs and exponentials are inverse operations. That is, if your x is located as part of the log, then what you need to do is use an exponential. And if your x is located as part of an exponential, what you need to do is use a log in order to find it. So therefore, to undo an exponential we use a log, and to undo a logarithm we use an exponential.
Now, as you've just seen in that little bit of the introduction just there, where we're talking about how to solve for an unknown when dealing with logarithms, the unknown value could actually be found in one of 4 positions, as marked by the 1, 2, 3, and 4 here. That is, the unknown could be found in position 1, it could also be found in position 2, it could also be found in position 3, or of course in position 4. So let's now go through and have a look at a worked example on how to solve for the unknown when it's in position 1. Let's check it out.
Right, so we're going to have a look at solving logarithmic equations where the x is in the very first position that I referred to earlier on, that is over in this position over here, if you look over to the right of the screen, in position 1. Now, what we're going to do is we'll look over here at the left hand side of the screen now, and as you can see, for position 1 you've got log x in position 1 here, 2, 3, 4. That is position 2, 3, and 4. So we've got x in position 1 there, like so. Now let's have a look at an example where we've got 2 log x, 25, is equal to 4. Now what we're going to do is we're just going to circle the thing that we're looking for like always, so therefore that's the x, and what we've got to do is just use inverse operations in order to solve for it. Now the first thing we need to do is go the furthest away from the x, which happens to be this 2 over here, because it's saying 2 times log x, 25. So the first thing we need to do is divide everything by 2, so that's going to get us log x, the 25, and when we divide both sides by 2, well the 2 is going to cancel out like so, and the 4 divided by 2 is going to be equal to 2. So you end up with log x 25 is equal to 2. Now this is the new move that you probably haven't seen before, and that is if you've got log x 25 is equal to 2, what we've got here is basically log x, and to undo a log what we need to do is an exponential. And to do that, what we're going to do is just draw this x down here like so. So we put x as the base and x as the base of the 2 here. So what happens when we do x as the base here is when you get x log x, that actually cancels out like so, leaving us with just 25 is equal to, and we did x as a base here, so you get x squared like so. Now all we need to do is just find out what squared gets us 25. Well, if we just square root that, so we go square root of 25 is equal to x, therefore x is equal to plus or minus 5. Now if you have a look up the top here, it says x must be greater than 0 because you can't have a negative value for this part here. So what we're going to do is just take the positive one. So therefore we'll just come up here and say x is equal to 5. So now what I want you to do is press pause and attempt the following questions. That is, solve the following. Log base x 125 is equal to 3, and 1/2 log x 64 is also equal to 3. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back. Now as you can see, for the first one we've got log base x 125 is equal to 3. What I've done here is just rewritten out the question. But what I'm going to do is I've got to get rid of this log x, because to undo a log I need to use an exponential. So to do that I just write the base of x for both sides like so. Now when you've got x log x, what happens is it actually cancels out like that, leaving us with 125 is equal to x cubed. Now to undo x cubed, what we need to do is just the cube root. So you do the cube root of 125 is equal to x, therefore you get x is equal to 5. Now for part B, you've got 1/2 log base x of 64 is equal to 3. So as you can see here, I've got the 1/2. What I've done is scoop that up and put it up here to make the 3 layers of ice cream that I've spoken about before. Now you've got log x 64 to 1/2. Now if you remember back to the earlier sets in this topic where we had something to the power of 1/2, well that's the same as saying the square root of something. So you've got log x 64 square rooted. Now if we go through and square root 64, we get 8. So you get log base x of 8 is equal to 3. Once again, our x is part of a log, and to undo that, what we need to do is put it to the base of an x. So to undo a log, what we use is an exponential. So you get x log x, and that actually cancels each other out. So you end up with 8 is equal to x to the power of 3. Now when you've got 8 is x to the power of 3, we just need to cube root 8 to get x, and that leaves us with x is equal to 2.
Awesome, so that's position 1 done. Let's go through now and have a look at how to solve logarithmic equations when the unknown is in position 2. That is what you can see here. Let's check it out.
Alright, so now what we're going to do is look at how to solve logarithmic equations with x being in the second possible position. That is where you've got x being here. So what we're going to do is have a look at this first example where you've got log base 6. So what we're going to do is have a look at this first example where we've got log base 6 of x is equal to negative 2. Now as you can see here, the x is part of the logarithm, so what we need to do is actually use an exponential in order to undo it. And we can figure out which exponential to use because we look at the base here. Now that's 6, so what we're going to do is we're going to write this out as 6 log 6x is equal to 6 as the base to the negative 2. Now when you've got 6 log 6, what happens is that cancels out, leaving us with x is equal to 6 to the power of negative 2. Now that there is going to be x is equal to 1 over 6 squared, or that is equal to 1 over 36. So now what I want you to do is press pause and attempt the following questions. That is for A, log base 10 2x is equal to 1, and for part B, solve log base 2 of 3x plus 1 is equal to 4. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back. Now if we have a look at the very first example where we've got log base 10 of 2x is equal to 1, what we need to recognise is that the x is part of the log here, so in order to undo it, what we need to do is look at the 10, as you can see here, and use an exponential in order to be able to undo it because it's a log. So we're going to do base 10 here and base 10 here. Now when you've got a 10 as a base for an exponential log 10, what we can do is cross that out like so, leaving us with 2x is equal to 10 to the power of 1. So you've got 2x is equal to 10 to the power of 1 as you can see here. Now 10 to the power of 1 is 10, so you're left with 2x is equal to 10, and when you divide both sides by 2, like so, what you get is x is equal to 5. Now for part B, we've got log base 2 of 3x plus 1 is equal to 4. So once again, the x is part of the log, so in order to undo the log, what we need to do is put a base of 2 because of this 2 here. Now the 2 log 2 cancels out, leaving us with 3x plus 1 is equal to 2 to the power of 4, as you can see here. So 3x plus 1 is equal to 2 to the power of 4. Now 2 to the power of 4 is 16, so you get 3x plus 1 is equal to 16, and when we subtract 1 off both sides, like so, that's going to go away, leaving us with 3x is equal to 15, and divide both sides by 3, leaves us with x is equal to 5.
Now, as you're about to see, when our unknown is in position 3, that is here, it's not actually too obvious in the fact that it's actually in position 3 because it's generally given to us in an indicial form. So let's go through and have a look at how to first of all convert it from an indicial form into a logarithmic form where it's in position 3, and then how to go through and solve from that point on. So let's check that out.
Now in this case what we're going to do is have a look at how to solve logarithmic equations when the x is in position 3. That is up here like you can see here. So what we've got here is 2 to the power of x is equal to 7. Now if we have to think about this for a second, this actually looks nothing like what you can see here because there's not even a log written down. And the reason is because we've got an exponential, and of course to undo an exponential we need to use a log. So what we're going to do is just rewrite out 2 to the power of x is equal to 7. And what I need to do is try and get this x on its own. So I look here at this number and I know that if I do a log base 2 2 to the power of x, well then what I'm going to have is the x can go out the front, and that will help us out with solving this. But because I've done log base 2 here, what I need to do is also the log base 2 of the other side. So that is log 2 7, like so. Now when I've got the 3 layers, of course I can bring the x out the front, so you get x log 2 2 is equal to log 2 7. And of course log 2 2, well that's going to cancel out, isn't it? So you're left with x is equal to log 2 7. Now what's log base 2 7 equal to? Well, we need to use our calculator in order to find this out. So when you go through and put this into your calculator here, what you'll end up getting is an answer of x is approximately equal to 2.808. And that's the only way you can do it. You need to have a calculator in order to be able to solve this. So what I want you to do now is press pause and attempt the following questions. That is 5 to the power of x is equal to 8 and 10 to the power of negative 2x is equal to 7. Remember, when you're done to press play so you can check your answers out against mine. Alright, so welcome back now, and as you can see we've got 5 to the power of x is equal to 8. Now we've got an exponential, and the x is part of the exponential, so in order to be able to undo an exponential we need to use a log. So what we're going to do is rewrite this as being a log base 5, 5 to the x, and log base 5 to the 8. Now as you can see here, what we've got is a log 5 5x, so what we can do is move the x out the front because it's a third layer, and bring it down, getting us x times log base 5 to the 5 is equal to log base 5 to the 8, as you can see here. So now if we have a look, log 5 5, well we know that's equal to 1, so we can pretty much just get rid of it and leave it with x is equal to log base 5 to the 8. And when I go through and put that into the calculator, what I will get is 1.292. So therefore x is approximately equal to 1.292. Now for part B, I've got 10 to the power of negative 2x is equal to 7. So once again I have a look here. Well, I've got an exponential and x is part of it, so what I need to do is use a log to undo it. So I go log base 10, because the 10 here is what we want to get rid of, and that's also going to be log base 10 of both sides. So you get log 10 10 negative 2x is equal to log 10 of 7. Now 3 layers once again, so the negative 2x is going to come out the front, leaving us with negative 2x times log 10 10 is equal to log 10 7. Once again, log 10 10 is equal to 1, so that's going to go away, leaving us with negative 2x is equal to log base 10 of 7. And of course, what I need to do now is divide both sides by negative 2, like so, and that's going to get us x is equal to log 10 7 divided by negative 2, because of course log 10 7 is actually equal to a number. So you get x is equal to log 10 7 divided by negative 2, and when we put that into the calculator we get an answer of x is approximately equal to negative 0.423.
And of course, going through and solving logarithmic equations where our unknown variable is in position 4, like you can see here. Now in this case, what you're going to need to do is go through and simplify the logarithm using one of the 5 log laws that we've seen in previous lessons, and then rearrange and solve for your unknown variable. So without waiting any longer, let's go through and check out a little bit of a worked example on how to do just that. Let's check it out.
Right, so finally we're going to have a look at how to solve a logarithmic equation with x being in the 4th position, as you can see here. That is, you've got the log on one side and it's all equal to your x. So what we're going to do is have a look at this example first of all. So you've got log base 3 of 9 is equal to x minus 2. So as you can see here, the x is in the 4th position. Now what we need to do first of all is simplify this log. So this is going to be equal to log 3, and 9 we can rewrite it as being 3 squared, like so. And that's going to be equal to x minus 2. So when we've got 3 layers, what we can do is bring the 2 out the front, so you get 2 log 3 3, like that, and you get make that equal to x minus 2. Now log 3 3, well that's equal to 1, so we can pretty much just cross it out, so you got 2 is equal to x minus 2, and when we add 2 to both sides, what we're going to end up with up here is 4 is equal to x, therefore x is equal to 4. So now what I want you to do is press pause and attempt the following questions. That is, solve the following. Log base 9 of 1 is equal to x, and a log base 10 of 1 over 100 is equal to 2x plus 4. Remember, when you're done to press play so you can check your answers out against mine. Alright, so welcome back. Now as you can see, we've got a log base 9 of 1 is equal to x, so I've rewritten out the equation, and of course what we've got to recognise is that whenever you've got anything, any base that is of log, and we make it to 1, that's actually equal to 0, so we end up getting the answer of x is equal to 0 because of this 1 here. Now for part B, we've got log base 10 of 1 over 100 is equal to 2x plus 4. So what we need to do is rewrite this 1 over 100 as being 10 to the power of negative 2, because it's the same as saying 1 over 10 squared. So you get log base 10, 10 to the negative 2, and of course we've got 3 layers now, so I can move this top layer out the front, getting us negative 2 log 10, 10 is equal to 2x plus 4. Now when you've got log 10, 10, that's actually going to cancel out because it's equal to 1, so you end up with negative 2 is equal to 2x plus 4. And now what we need to do is subtract 4 off both sides, minus 4, gets us negative 6 is equal to 2x, and when we divide both sides by 2, we're going to get x is equal to negative 3.
But really though guys, the key to solving logarithmic equations isn't actually knowing what position the unknown variable is in. It's as simple as knowing that if the unknown variable is part of a log, then what you're going to need to do is use an exponential to undo it. Whereas if the unknown variable is part of an exponential, what you're going to need to do is use a log to undo it. So of course, like always, make sure you stay tuned for the very next lesson and say hi to your maths teacher for me, or yeah.